Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. So we define a function big F through this integral, the integral from 1 to cosine x, as the integral of e to the t squared dt. And we want to show that big F is differentiable everywhere, and we want to find its derivative. Okay, so our function is defined through this integral, so this gives us a clue. We want to be able to apply the fundamental theorem of calculus. However, we've got a problem. We've got this composite bound here. Instead of just x, we've got cosine of x there. So that is a problem. So what we will do is we will define a new function and we will call it g. So let us define g from the reals to the reals. And how do we define g? We define g as follows: 0 integral from actually not from 0, we want to match the lower bound from 0, but instead of cosine x we just write in an x, and we look at e to the t squared dt. And now the function that sends t to t squared, this is continuous everywhere, since this function is continuous everywhere by the fundamental theorem of calculus. It's the other way around. Fundamental theorem of calculus. What do we have? That we can write down what the derivative of g is. And what is the derivative of g? That is just our integrand with the t's replaced with x's, and this is for all x in the real numbers. Okay, but we're not interested in the derivative of g, we are interested in the derivative of f. But now we can see g and f are related. How are g and f related? So f of x, that is the integral from 1 to cosine x, e to the t squared dt. But this is g composed with cosine x. So here we have replaced the x there. Okay, and now by the chain rule, now we apply the chain rule to this function. So the derivative of f, that is going to be the derivative of g applied to cosine x multiplied with the derivative of cosine x, which is minus sine x. But we know what the derivative of g is. The derivative of g is e to the x squared. So this is going to be minus e to the cosine squared x sine x. And there we are done. That is it for this example. I will see you in the next one.